Hi, my name's Jeffrey Hanson. I'm a senior research scientist at Carleton University, working in Professor Joe Bennett's research group, and I'm here to talk to you today about the Where to Work tool. In our previous videos, we covered the underlying principles that govern the Where to Work tool. We also covered the terminology and how the Where to Work tool can identify priority areas. And in this video, we'll be providing a practical demo of the Where to Work tool. So to access the tool, you'll need to visit ncc.carleton.ca, and I recommend using Google Chrome for the best experience. When you visit this website, you'll see that there's two options for signing in. One of these options is for staff members of the Nature Conservancy of Canada. If you are a staff member of NCC, I recommend contacting Richard Schuster and he can provide you some login details. This will provide you to private datasets that aren't open to the public. If you're not a member of NCC, you can use the public sign-in option instead. Note that under both of these options, you have the ability to supply your own data and use these with the Where to Work tool. Today, we'll be using the public access sign-in. So we'll click the sign-in button. And then we'll see that we have a variety of tools that are available. Since we're using the Where to Work tool today, we'll be using the Where to Work tool. And specifically we'll be using the advanced version, and this provides additional functionality and the ability to specify settings in a more granular detail than the beginner mode. So let's click the launch button under Where to Work Advanced. After the tool is finished loading, we can now specify how we want to obtain our input data. If we want to use a built-in project, we can select it from the menu under built-in project, and here's a sample of different built-in datasets that you can use with the tool. You can also specify your own data instead. If you have specified your data using a very specific file format that's designed for the Where to Work tool, you can select Upload Project Data and specify the files under this file format. If you haven't specified your data using this very specific file format for the Where to Work tool and instead have data in a different format, I suggest preparing your data as a shapefile and then using the Upload Shapefile option. Once you specify this data format, you'll be able to then specify for each of the attributes, so each of the columns in your attribute table, whether they're a theme, a feature, an include or an exclude, or a weight. It's also worth noting that when you upload your own data, this isn't retained by the tool. So in other words, once you close your web browser session, any data that you upload to the tool is deleted. So you can be confident that any confidential data will remain private. But today we're going to use a built-in dataset, so we're going to select built-in project, and we're also going to be using the Southwestern Ontario dataset. So once we've specified that, let's click the import button. After the tool is finished loading in the data, we can see that we have two sidebars, and we have a map in the middle. Let's close the right sidebar and focus on the left one to begin with. So we can see here we have a map, and this table of contents panel in the left sidebar. This allows us to control which datasets are shown on the map, and also what order they're shown in. So for example, let's click this button here to hide all the layers. And we can see here that we have one theme called Critical Habitat. And we know this is a theme because it has a star icon. And within this theme, we have multiple different features. For example, we have one feature, which is the eastern fox snake. If we click on this button, this will then render the distribution of the eastern fox snake on the map. And we can see based on the legend here that this dataset for the eastern fox snake contains presence and absence data. So these places shown in yellow, these are places that contain critical habitat for the eastern fox snake. We can also see that this dataset was derived from a national dataset as shown by this icon. In addition to critical habitat, we also have features and themes related to species at risk, shoreline data, and land cover datasets. If we render multiple datasets, we can look at areas where they overlap. So we can see here, these are places which contain both forest and the eastern fox snake, and in particular places that are yellow in the forest data set, these are places with a lot of forest, and so places that are bright yellow in areas where they overlap are places that contain the eastern fox snake as well as large amounts of forest. In addition to themes, we also have data sets that correspond to weights. So for example, we have a weight which corresponds to carbon potential. Let's just show that on the map. So areas that are dark orange or brown, so these places here, they have very high carbon potential, whereas places with a light yellow, like such as this place here, that contains very low carbon potential. We also have a weight that corresponds to the human footprint index, which describes total human pressure. And here, places that have a light orange color have very high human pressure. So for example, these grid cells here, or these grid cells over here. Some of these weights correspond to places that might improve conservation efforts, and other weights might correspond to places that might impede them. We'll go into this a bit later when we use the weights to generate prioritizations, but it's worth bearing in mind for the moment. We also have includes. These are shown by the padlock. Wrong layers. We also have includes. These are shown by the padlock icon. These includes include existing conservation areas and military bases which have been flagged as OECMs. You can have a look at them, and they're shown in the green places here. These might be places that we might want to lock into our prioritizations, so any priority areas we identify will be building off and enhancing these existing conservation areas. We also have excludes, which is shown by this icon, and these might be places that we might not want to select as places that are priorities for conservation, because they might have conditions that make it difficult to implement conservation areas. Okay, so in addition to this table of contents sidebar, we also have these buttons available on the map for interacting with the map. So we can use the plus and minus buttons to zoom in and out. We can click on the home button to reorient to the center of the study area. We can quickly hide all layers on the map by clicking that button. This question mark button opens up a dialog which has a brief explanation of the different buttons and terminology in the Where to Work tool. If you want more information, I would suggest reading the user manual. And we can also use this button here to change the color of the base map. I find a grayscale base map to be very useful because when we generate prioritizations with different colors, that makes them stand out. If we want to download any of these data and explore them on our own computer, we can go to the Download Data sidebar, and we can select the layers, so the features or weights or includes or excludes that we want to download spatial data for. It's also worth noting after we generate some prioritizations, we'll have the option to specify them here so we can download them for later. Okay, in addition to these sidebars, we have a sidebar with contact information if you have any questions. And we also have an acknowledgement sidebar which lists the various people that are involved with developing the application and also the software libraries that underpin the Where to Work tool. So the left sidebar is primarily about visualizing data. The right sidebar is all about generating solutions and evaluating them. So we can see here, for example, we have one theme here, critical habitat, and we can use these buttons on the left sidebar to visualize them on the map. These settings here in the right sidebar are used to specify the goals for these themes, so that when we generate a solution, it will ensure adequate coverage of each of these different features. So for example, if we're interested in setting a goal for the eastern fox snake, we currently have a default value of 20% coverage, but we could increase that to 30% if we wanted to. This green bar here, current, this is showing the percentage of the eastern fox snake's distribution that's currently covered by the includes that we have toggled on. By default, we have both the existing conservation and military bases includes toggled on, and so we have a 3% coverage. If we toggle them both off, then we would see that the current coverage goes down to 0%, and that's because we don't have any includes toggled on. Let's toggle them back on though, because that's good practice. And so we can use this under single goals here to specify individual goals for each of the different features in our themes. If we wanted to assign each feature within the same theme to a single goal, we can use this slider here. So for example, we could say that each and every feature within the critical habitat theme must have 30% coverage at least in the solution. This would be how we do that. But let's just stick with the single goals to be more explicit here. We can also open up the weights option here. And so if we wanted to, we could toggle on some weights and use these to influence which places are selected for prioritization. Let's do that in the next prioritization though, to keep things simple to start with. And as you can see here, we've got our includes toggled on and we don't have any of our excludes toggled on. Under the settings pane here, we have additional settings that control the overall prioritization, but let's look into that later. So just to recap, what we'll do here is we're going to set our goals for the eastern fox snake to 30%. Let's also set a goal for forest to be 30% as well, and leave everything else as defaults. Now, to generate a solution, we're going to type in the name of the solution. Here it's going to be Sol 1, and we're going to leave it as the default red color. So let's clear our map, and then let's click Optimize. So now the Where to Work tool is reading all those settings that we specified. So our goals for our themes and our features. It's also looking which weights we toggled on and which includes or excludes we have toggled on. It takes all that data and those settings, turns that into a mathematical optimization problem, and then solves that, and then renders the solution. So we can see here that it's identified these places in red as priority areas for meeting our objectives, which we specified here in our Generate Solution sidebar. And it's opened up by default the Solution Results sidebar. So the Solution Results sidebar is used to evaluate how well solutions meet our overall objectives. The summary pane contains a description of the settings used to generate the solution. So we can see here that, for example, we didn't specify a budget or any spatial clustering. The statistics section here, this provides information on the spatial distribution of the solution. So we can see that 2,900 planning units were selected, or here 2,900 grid cells. We can see that the total area was 2,900 square kilometers. And we can also see that this represents 21% of the total area under consideration. We can also see that 510 reserves were selected. A reserve is a spatially contiguous set of selected planning units. So this mass here represents one reserve, and this single rectangle here represents another reserve. In addition to understanding the spatial distribution of the solution, we can also see how well it captures our themes and how well it reflects the weights and includes. This is really important to understanding how well the solution actually performs. So we can see here we have a different plot for each different theme. Since the critical habitat and species at risk plots are a bit difficult to understand, let's take a look at the land cover plot to keep things simple. So we can see here land cover has two themes. We have a forest, has two features. We have a forest feature and a wetland feature. The forest feature has a goal of 30%, and that's because we set it as 30%. We can see the include was 8%, and so this means that given the includes that we specify, 8% of forests were already secured. We set a goal of 30%, and our solution covers 38% of forests, so it's met that goal. In a similar way, we could look at wetland coverage. Includes covered 9% of wetlands. Our goal was to secure at least of 20% of wetlands, and our solution covers 62%. Now you might be thinking 62%, that's a lot larger than 20%. And the reason why this percent is so much higher is because in order to meet all the goals for all the other themes and features, such as critical habitat and species at risk, we had to get much more wetland than we had as our goal in order to achieve all the other goals for all the other features. Because we didn't specify a budget when generating this prioritization, it's guaranteed to identify a solution that will meet all the goals. Now, although we didn't use a weight when generating this solution, we can still evaluate how well this solution covers the different weights, because the way to work tool will automatically overlay the solutions with the weights and calculate coverage statistics, even if they aren't necessarily used to generate a solution. This can be useful so that we can then compare to see when we do consider these weights how much this changes our priorities. So for example, let's look at carbon potential. We can see that our includes covered 7% of the distribution of carbon potential, and our solution covers 36%. Similarly, if we look at carbon storage, we can see that our includes covered 6% of carbon storage areas, and our solution covers 26% of carbon storage areas. We could also take a look at another weight, human footprint. So while carbon potential and carbon storage are typically seen as positive for establishing conservation areas, human footprint is not seen to be the case. Often, so the human footprint layer describes total human pressure, and areas with greater human pressure are considered to have higher impediments for establishing conservation areas. And so here we can see that our includes covered 2% of the total human footprint areas, and our solution covers 17% of total human footprint scores. So let's try generating another solution now that explicitly considers these weights. So let's go to the weight. So let's go to new solution, then weights. We'll toggle on carbon potential and we'll set its weight factor as 100. Let's also toggle on carbon storage and set its weight factor as 100. So because we're setting them as positive values, this means that we want the prioritization to try and capture areas that have high carbon potential and high carbon storage. We've also set them both at 100, meaning each of these different weights should be considered equal. If we had greater preference for carbon potential than carbon storage, we might set our weight factor at a lower positive value, such as maybe 50. But for the moment, let's just set both of them at 100. Let's also toggle on human footprint, and now we're going to assign it a negative weight factor. This means that areas with high human footprint should be avoided if possible when selecting priority areas during the optimization process. So now let's generate the solution. So we're going to give this a different name. We'll call this Sol2, and we'll make this one shown in blue. And then we'll click Optimize. Okay, so let's just take a look at the map first. We can see that this solution 2 has been added to the map, and so we have red pixels, which are places that were only selected in solution 1, light blue pixels, which are places that were only selected in solution 2, and dark blue or purple pixels, which are places that are selected in both. So for example, we can see this area here was selected in both solutions, but there are some places, such as down here, which were only selected in solution 1. And there's several other places that were selected in either or. So if we look at our solution results sidebar, we can see the solution is covering a similar proportion of the total study area. It's still both covering 21%. And we can also see that our solution 2 is still meeting all our goals. An easy way to visualize this is because if any of these goals weren't met, this dark blue bar would be sitting in between the green bar and the light blue bar. But because the dark blue bar is always further along this radial plot than the light blue bar, which corresponds to our goal, then we know that this goal is always being met. But we can also mouse over and check the numbers to be extra sure. Let's look at the weights. This is where we expect to see some differences. So we can see here that in solution 2, where we had a negative, let's look at carbon potential first. So we can see here for solution 2 where we had a positive weight factor of 100. Our includes covered 7%, and our solution is now covering 41% of carbon potential areas. Whereas we look at solution 1, we can now see that it's gone up from, originally we had 36%, and now it's up to 41%. So that's an increase, and that's because we assigned a positive weight factor for carbon potential. In a similar way, we can see that in our first solution, we obtained 26% coverage. But if we look at solution 2, we now have 27% coverage, so that's increased as well. Now let's look at human footprint. Now remember that we specified a negative weight factor here because areas with greater human footprint index correspond to areas of greater human pressure, and such places are associated with greater impediments for establishing conservation areas. So in our original solution, we had a total coverage of 17%, and now in our new solution, we've got a total coverage of 15%, so that's gone down by 2%. If we wanted to reduce this even further, we might have to compromise on our goals by reducing them, or we might have to compromise by reducing our weight factors for carbon potential and carbon storage so that the human footprint index has a greater influence on the prioritization than these other weights. Now let's look at setting some includes. So we can set an include, let's look at setting some excludes. We can set an exclude by going to the excludes well and then clicking on major highways and urban areas to activate them. That's pretty simple. So now, just as before, we'll generate another solution. Let's call this solution 3. Let's make this one shown in green and click optimize. Okay, let's look at the summary for this solution. We can see we're still covering 21% of the study area. Now let's compare it to solution 2. So here, solution 3 is on top of solution 2. So places that are shown in blue are places that were selected in solution 2 but not in solution 3. And these light green areas are places that were selected in solution 3 but not in solution 2. And these dark green areas are places that were selected in both. So we can see that when we specified these excludes, it didn't really have much of an influence on our solution. This is possibly due to correlations between our weights and our excludes. For example, we have urban areas as an exclude, and we might expect places that are classified as urban areas to have higher human pressure scores, and so we're already kind of capturing that when we specify weights with a negative weight factor for human pressure. So let's generate a fourth solution now. So far we've been generating solutions without a budget. So let's also toggle off our weights just to keep things simple. So far we've been generating solutions without a budget. This means that the solutions will always meet the goals. Let's try generating a solution with a budget of 10%. So now this means that the Where to Work tool is going to generate a solution that tries to get as close as possible to meeting as many goals as it can, but it will never exceed this budget of 10% of the total study area. So in our previous video, we talked about the different mathematical formulations that the Where to Work tool uses. When we do specify a budget, we're using the minimum shortfall formulation. When we don't specify a budget, we're using the minimum set formulation. And this can have a pretty big influence on our results. So let's take a look and see what happens. So let's call our solution Sol4. And let's also make this one shown in pink and click optimize. Okay, so we can see here that now our solution is covering 10% of the study area, which is meeting that area budget. We can also see that many of our features are no longer meeting their goals. For example, if we look at the land cover theme, the forest feature has an include of 8%, a goal of 30%, but the solution is only covering 16% of forests. So that goal is not being met. If we look at wetlands, we can see the goal is met because we had a goal of 20% and the solution is covering 20%. To get a better understanding of which features are meeting their goals, we can click on this table icon here. And this provides tables that provide greater detail on how well our solution is meeting our objectives. So the first table just contains our summary statistics. But if we click on this button here, this will show us a breakdown for how well each feature is meeting its goal. So for example, we can see that the eastern fox snake is not meeting its goal because we had a goal of 30%. and the solution is covering 29% of its total distribution. And so the goal is not met, and that's indicated by this red cross. On the other hand, the western chorus frog has a goal of 20%, and the solution is covering 20.1% of its distribution, so that goal is met. And so in the met column, we have this green tick. So if we scroll down, we can see exactly which features are meeting their goals and which ones aren't. In this tabular view, we can also have more information on how well our weights are covered by the solution as well. So for example, we can see that our solution covers 15% of carbon potential areas and 12% of carbon storage areas. If we look at the includes, we can see that our solution is covering 100% of existing conservation areas and also military bases. If we look at the excludes, we can see that we have a non-zero value for coverage here, and the reason for that is because our includes take preference over our excludes. So if there are overlaps between any of our includes and excludes, if a place is selected as an include, then it will automatically be included and it won't be excluded. And so that's why we have 1% coverage of major highways and 3% coverage of urban areas. If we want to change that, that's an option in the settings. So let's take a look at all our different solutions. We can see that although there's some differences between each of the solutions, there's definitely some areas that emerge as being selected across all four of these different solutions. So for example, this dark purple area here, this dark purple area here, and these dark purple areas here. So as we can see, when you generate solutions, the results that you get do depend on the goals and weight factors that you use, and also your includes and excludes. So if you're not sure what specific setting a goal should have or a weight should have, I would suggest generating multiple solutions with different values that might make sense to you, and then seeing if that really has an influence over your solutions, and also seeing if there's common areas that emerge across different runs. And these might be places that you can be sure are high priority regardless of the uncertainty that you have over which particular parameter or set it, like such as a goal or weight factor has on a regardless of whether the specific value you think that should have. Because if it's a priority across all of them, then that suggests that it's fairly robust to that uncertainty. After generating these solutions, you can click on the download data options and select these solutions to download them. And this will then download this information to your computer, and then you can look at that in your preferred GIS environment, such as QGIS. And so that's everything for today. So thank you very much for listening to me. If you have any questions about the Where to Work tool, I suggest reaching out to Richard Schuster at NCC. And here again are the links where you can access the Where to Work tool and also view its source code on GitHub. Thank you very much for listening to me, and goodbye.